Hello, welcome to the video for 61 and 62. Now this is the packet, this is what it looks like. It says MC32 at the bottom, and be careful, be careful, be careful, because 61 is on the back. I tried to save a little paper, and 62 is here. And I'm actually going to start explaining 62 first because it helps me explain 61. So starting with question 61, let's take a look. It has a classic back-to-back stem and leaf plot we're looking at. The question says the back-to-back stem and leaf plot below shows the percentage of students who dropped out of school in 49 high schools. So we compared this one year, and then we compared it in another year. The reason why they give you 2 years is a school year. So this is really just 2 school years. I'm going to write the word before just to help us keep track, and then after. So this was the before, so earlier, and then we later on took a look at this. Now a couple things from stem and leaf plot I just want to review really quick. We can still tell skewness really well from these things. So this would be the tails going off to the right, so this would be right skewed. A lot of times I have you compare the shape of these. Now the one thing you got to be careful of is that this other side you have to imagine is mirrored or flipped over. So this looks like, if you looked at the numbers, would be skewed left. But in fact, notice this butterfly, if you folded this wing over, it's definitely the same skew. This is also right skew. So again, keep in mind that the right skew is correct for the one to the right of the stems, but not to the left of the stems. You have to imagine that one flipped over. Both of these have the same skewness. So now let's take a look at the problem. It says there's 49 skews, and they'd like us to compare if it decreased. So that sounds like why you would have done the study, to figure out, does the dropout rate, is it going down? So both A and C are saying the dropout rate decreased. So we're thinking, okay, let's decide if it did. So in general, when data is skewed, we look at the median. So if I look for the median, I want you to know how to calculate the median of 49 pieces of data. So if you're trying to calculate the median of 49 pieces of data, you're just looking for the middle number. So to figure out what number would be in the middle, we divide by 2, and I get 24.5. That means that the median number, there's going to be 24 numbers to the left, and then there's the median, and then 24 numbers to the right. And so that should make sense that if 24 plus 1 plus 24, all those added up to 49. If I had 49 schools and I put them in order least to greatest, the one in the middle would be the median, which would mean 24 would have a score that was less than the median, and 24 would have a score greater than. So any odd number has an exact median. So I need to just count up 24 from the bottom or 24 from the top, and I'm going to go ahead and do that. And I count up 24, and I figure out that it is this very first 3 there. Okay, so the median in the later school year is 13. So on average, a typical school has a dropout rate of 13, which means that 87 are graduating. Now let's compare it to here. Same thing, they said 49 schools, so I'm just going to count up from the front or the back, 24, and I end up getting the number 16. Now be careful, if you're counting from the bottom, you want to count from the bottom here, from the lowest number all the way to the highest. We get to right there, 16. So it does appear as if it did decrease. 16% dropped out in 89-90 and only 13. So why aren't A and C both right? Well, there's something wrong with A because it says each high school decreased. So the problem with the stem and leaf plot is I don't know that maybe this one was bogey before and this one's bogey after. I can't tell which high school. I just know that 49 schools were before and 49 after. So definitely A is the one that something is wrong, and the problem that's wrong with it is this word each. But it is true in general, we know as a group they went down. just by comparing the medians. The E says that the range really didn't change, so that's just max minus min. So if I count before, the max was 37 and the min was 9, so that's a range of 28 percentile. And the max after was 35 and 4, the min was 4. So the range, it is true, the range didn't change that much. It went from, dropout rate range from this to this, and so that's pretty close to the same number. Notice the widths of both are pretty close to one another. So that's why the other two must be true that we didn't talk about. Now let's talk about 61. So you saw me actually calculate the median in this last question. Notice the question 61, again, keeping in mind it goes before, says we sampled 25 employees and we made a mistake. So imagine, if you will, that there was a mistake here. So it says, imagine there was a mistake and the greatest number we accidentally got off by 10 times as much. So imagine this data value was off. That would move it way up, would totally throw things off. Notice that would have totally fumbled up my range. And wait a minute, it wouldn't have made any difference at all with my median, because the median was the number in the middle. So even if I moved this number way high or this number way high, the number in the middle would still have been the same. The mean would have changed, because that's adding all these up and dividing by 49. That totally would have changed. The mode, the number that happened the most, that could have changed. It might not have changed, but definitely I know for sure when you have 25 numbers, if you divide that in 2, you get 12.5. That means 12 numbers were above, 12 numbers were below, and one number is in the middle. If one of the high numbers or low numbers changes, that median stays exactly the same. Therefore, my answer to 61 is median. Thank you for joining us.